Welcome all. Today is an interesting session where the Institution of Naval Architects is presenting a panel discussion on opportunities in naval architecture. This is a very contemporary topic when, as a subject, naval architecture is in the cusp of a changing paradigm, and this presents new opportunities to the next generation of naval architects. To navigate through this topic, we have the privilege of having a panel of naval architects with experience varying from a decade to about 4 decades, who have collectively seen the evolution of the subject and the opportunities that they present. I, on behalf of INA, welcome all the panelists and the participants, particularly those who have joined from various colleges in India and their faculty. To start the session, it is my privilege to invite the chief guest, Mr. Girish, and the panelists, Commander Karthik, Mr. Jathesh Chandra, Mr. Hariraj, and Mr. Ankur. I take this opportunity to introduce the chief guest of today, Mr. Girish. Mr. Girish is a naval architect with a BTech degree in naval architecture and shipbuilding from Cochin University in 1982, MTech in ocean engineering from Yokohama National University in Japan. He has worked at Mazagon Docks in their design department before joining the Indian Register of Shipping in 1991. At IRS, he has been involved in plan approval, rule development, and research activities. He is currently Senior Vice President and Chief Surveyor at IRS, looking after rule development and associated research. Mr. Girish has been associated with IMO and ISES activities for many years and has been representing India as a member of the delegations at IMO meetings. With this short introduction, sir, I request the chief guest to give his opening remarks on the topic.
Thank you, Dr. Iyengar. First, I would also like to thank INA for organizing this meeting and honoring me by inviting me as the chief guest. I consider it to be a big privilege to be here. For the topic of the day is opportunities for naval architects, naval architect in naval architecture. In fact, when I think about that, I remember the slogan, a sea of opportunities. That's what the Navy says. In fact, naval architects have got a sea of opportunities, especially in the present times when a lot of challenges are happening, a lot of changes are happening in this field, especially in the field of decarbonization and digitalization. So this is coming into our field, and when we go to various areas of our work, like for example, the naval architects are employed in ship design companies or shipyards for ship construction. Then there are research institutes, classification societies, regulators like the DGS and MMD, ship owner naval architects. Then Indian Navy is there, and of course the academics and research-oriented people can do that also, and various new areas where naval architects can get in. And this is a field which is really a promising field if you remain in the field, because of the opportunities which are coming. And if you stick on to your in this field, and you go with the challenges and try to find solutions to the various problems which we are facing today, mainly from the decarbonization point of view. We are talking about alternative fuels, how to improve energy efficiency, and how to in fact, the alternative fuels will come with a lot of their own problems like toxicity or fire safety, explosion safety. All these challenges have to be overcome. Then you need risk assessment. You need maybe this kind of fuels like what we talked about, like hydrogen, ammonia. Ammonia is a highly toxic fuel. You have issues like dispersion of ammonia, and it affects the people. And the crew should be confident enough to work on such a ship. So you should make a good design. In fact, all this is a challenge for naval architect to make a good design and arrangement of the other ships so that ships can be propelled with this kind of new fuels. Then we also, in fact, we are also going back to the wind propulsion. It has not the type of sails what we had. There are new types of mechanisms like rotors and all are available. So that also gives you some additional power to reduce your emissions. So like that, big challenges are available. And in the field of digitalization, I would say there are. Today, we also talk about fully autonomous ships, even though we are not reached there. A lot of autonomy is coming into shipping, and various levels of autonomy is being talked about. So all this giving you wide range of opportunities and challenges to work in the various areas wherever you choose to work. And we are always either you can be a, I would say, you can work as a green crusader working for green shipping, or you can also work for in the digitalization field. If you think that okay, I want to work in something like a fully autonomous ship, maybe there are opportunities available there also. So you can be in the forefront of technology by remaining in this field. That's what I would like to emphasize. Today we have got a list of panelists, expert panelists from representing various fields like design, construction, the Indian Navy, academics, etc. And so we will hear from them, and then with their experience, they will be able to guide you further and describe the further opportunities which are available. So after that, we will again come back to our discussion after we hear from the panelists, and wish you all the best. And I welcome the panelists for their discussions. Thank you.
Thank you, sir, for your encouraging and very comprehensive opening remarks, which was covering the entire gamut of where naval architecture is going towards. I introduced the first panelist speaker for the day, Commander Karthik Das. Commander Karthik Das was educated in Hyderabad and Bangalore. Then he did his some amount of schooling in Bangalore, and after that joined the Navy and was commissioned in 1997. He had undergone his naval orientation in INS Shivaji Lonavala, graduation in naval architecture in Cochin University, post-graduation PG diploma in warship technology from IIT Delhi, and after that he has held various postings in Indian Navy, which was covering dry docking of ships, floating dock at Port Blair, graving dock and slipway at Visakhapatnam, and shiplift, and also associated with overseeing of new warship and yardcraft construction in Kolkata, Pan Navy procurement and policy decisions making at integrated headquarters at New Delhi, as well as headquarters Karnataka Naval Area at Karwar. And he was also associated with ship repair for frontline warships, including aircraft carrier INS Vikramaditya. Towards the end of his naval career, he was also associated with 6th Karnataka Naval Unit NCC Udupi as commanding officer. And finally, he decided that he would seek civilian appointments, and so he left the Navy on 31st of July 2023. He was, as far as awards are concerned, he was adjudged the best passing out officer in the Construction Technical Orientation School at INS Vishwakarma, earlier known as Shipwright School, and received a commendation of Commander-in-Chief, HQ, Eastern Naval Command. And post-retirement, now he is working at Alstom Transport India, Bangalore, in a project management role. His hobbies are reading, swimming, listening and playing music, art, and interacting with the youth. And welcome you, and you can just please your views on the topic, Commander Karthik Das.
Thank you so much, sir. Respected Girish, sir, eminent panelists, Dr. Bharadwaj, thank you very much, sir, for giving me this opportunity to be here today and speaking to our young and budding naval architects who are looking for future and career in naval architecture. As already highlighted by you, sir, I have had an opportunity to spend nearly 2.5 decades in the Navy. After my initial orientation and training, I have been part of various aspects pertaining to naval architecture. In my initial appointments, I was in an industrial production role. I was in Naval Ship Repair Yard, Port Blair, wherein I was associated with, let us say, fabrication, outfitting jobs, repairs to warships. Subsequently, I have had the opportunity to be dry docking, associated with dry docking in various formats. Basically, I was assistant dock master in floating dock in Port Blair. I have also been deputy manager in dry docks and slipway at Naval Dockyard Visakhapatnam, and also in shiplift system. So effectively, Navy has given me the unique opportunity to be associated with all forms of dry docking, that is in a graving dock, in a slipway, in a floating dock, as well as in a shiplift system. This is a unique opportunity, and it gives you a very clear understanding of the various aspects of naval architecture, which we probably study in our initial days. And then when you actually practically apply it, especially when you're doing the various calculations and when you're supposed to do a very safe docking, the complete aspects of basic naval architecture, which you are supposed to look into when you are doing the operation itself. I have also had the opportunity to be associated with the repairs to frontline warships, including aircraft carriers, which has given me a lot of insight into other aspects, not only pertaining to naval architecture, but also, let us say, the engineering and electrical aspects, which is actually a very essential thing, especially when, let us say, somebody needs to look at, as Girish sir will agree, when I'm talking about surveyor, it is not merely naval architectural aspects which an individual is supposed to be knowing. It would also entail having a fair idea about, let us say, motors, pumps, and the way a lot of equipment run. So that kind of insight also you get. So I think I'm very thankful to the Navy for giving me that kind of opportunity to be associated with these aspects also. In addition to that, during my tenure in IHQ MOD in New Delhi, I was associated with the Pan-Navy procurement of boats. So therein, there was a requirement to look into the technical aspects, generating the technical documentation with regards to a specific requirement of what should be the, let us say, the GRP specifications, the various methodologies for repair, the OBS BND spares procurement. So all these aspects, gives you a very holistic view of how to go about when you're, let us say, procuring an equipment, when you're maintaining an equipment, what are the aspects that you're supposed to look into. That is the kind of opportunity that particular tenure has given me. In addition to that, I also gave cover for FDN2 when it was being constructed at L&T. So basically associated with all the design, drawing, vetting, as well as the various calculations associated with mooring initially when the jetty was not ready, when FDN2 was required to be moored off North Bay. So I have had the opportunity to go through the various calculations and identify whether the calculations that were provided by the shipyard were adequate and whether there were any other safety aspects that needed to be addressed also. In addition to this, I have also been associated with the policy decision making with regards to various naval architectural aspects for all our warships and yardcrafts. In addition to, let us say, aspects like load testing and the usual our steel, paints, electrodes, which are generally the mainstay of all our naval architecture specific subjects for the Navy. And of course, I would say that in my final tenure, I was associated with training of youth as part of NCC. It was kind of an arrangement that I basically opted for NCC, wherein I had decided that after, let us say, 20 years, slightly more than 20 years, I just wanted to broaden my perspective and move out of Navy. But I would say that the 20 plus years of exposure in the Navy to the various aspects of, let us say, production floor, to, let us say, design vetting, and of course, overseeing at Kolkata, as the sir also had told, that was actually one of the probably a very important tenure in my naval career, wherein right from, let us say, keel laying stage to delivery and post-delivery guarantee support, the various aspects of ship construction that I have been exposed to during my overseeing tenure has been some of the most, I think, important learning phases. And I still, glean whatever information or data when somebody asks me. I always look back to those days and whatever exposure that I've had at that point of time. That is I would say, that has added to my professional whatever capabilities, I would say, in the Navy during my overseeing tenure. Finally, I would like to just wrap up by saying that Indian Navy has got a very nice catchphrase: join the Navy, see the world. So in addition to doing the various, let us say, tenures at various places in India, my first posting was in Port Blair, Andaman Nicobar Islands. Subsequently, second tenure was in Kolkata, then Visakhapatnam, followed by Delhi, then Karwar, and of course, the final tenure in Udupi. I would say that in addition to giving you a very nice and holistic exposure to various aspects of naval architecture, If anybody would like to opt for Indian Navy as a career, I think it leads to a very holistic development. In addition to your physical fitness and mental alertness, your professional acumen also gets honed in a very, very holistic manner, along with the exposure to academia and frontline designers and shipyards. The learning is great, and I think as naval architects, we are a very sought after core in the Navy itself by virtue of the kind of professionalism that is brought to the table by the core as a whole. And I would say, as a naval architect, if somebody wants to opt for Indian Navy as a career, I would say it is definitely a worthwhile thing that one should definitely aspire for. I thank you, Bharadwaj sir, for giving me this opportunity to speak today. And I would like to wrap up my talk as of now. And probably after all the panelists have done the question and answer session, if anybody has anything, I would love to clarify any doubts, sir. Thank you, sir.
Thank you, Commander Das, for insights into the reference of Indian Navy. Of course, now the next panelist I would welcome is Mr. Jathesh Chandra.
I think, excuse me, Mr. Bharadwaj.
Yeah.
I think maybe there is a bit noisy because of heavy rain here. Maybe I'll come on. You can call me maybe after Hari or Ankur.
Yeah. So I'll just then I would like to call Mr. Ankur Anal first. Mr. Ankur Anal, if you're ready, I'll just introduce you first. He's a naval architect with more than 10 years of experience in an IACS classification society. Mr. Ankur Anal's experience includes design appraisal of ships and offshore structures, project management, survey of ships, rule development, and software development. He is working in Indian Register of Shipping since July 2013. He did his graduation in Indian Maritime University, Visakhapatnam campus, and currently doing his Bachelor of Science in Programming and Data Sciences in distant mode from Indian Institute of Technology, Madras. He has got experience in structural and statutory plan appraisal of ships, where he has done plan appraisal for FPSOs, tankers, chemical tankers, passenger vessels, floating docks, link spans, cargo lift, including techniques like finite element and CSR, bulk carrier structural plan, and statutory plan approval. Also, project management for more than 30 vessels, including cement carriers, passenger vessels, and oil tankers, jack-up barges, restoration of technical queries of ship designers, builders, owners, and surveyors at site, and led a team of qualified marine surveyors to deliver projects as per agreed schedule and fully supported all stakeholders, visits to shipyards to assess smooth progress of the project and new construction surveys, IACS related works and others, IRS team member for internal software development for checking compliance to IACS CSR, assisted IRS members in various tasks of the following IACS panels: Hull panel, EG, MNW, and PTPH32. Team member of IRS rule development for vessels fitted with fuel cells and autonomous surface ships. Young professional member of Bureau of Indian Standards, Building and its Applications Committee. I've already introduced his educational qualifications. He is a member of the Institution of Naval Architects and associate member of the Royal Institute of Naval Architects, London. And he's got familiarity with softwares, AutoCAD ANSYS, SACS, STAT Pro, MSc Patron, NAPA, Max, Shipflow, and has programming skills in Python and Visual Basic. With this introduction, Mr. Anal, please give your perspective on the topic.
So thank you for the opportunity provided to talk on this topic. To start with, I would say that naval architecture, I've been in this field for close to a decade now, more than a decade. And in my understanding, this is the most complete form of engineering. So it gives you an opportunity to see the ship as a whole, and whichever field you want to specialize in, whether it be just the design section or the machinery design or the operations, it gives you a complete form of engineering. You feel very satisfied with the job that you do. Now, coming to the opportunities that are there in the market, for the naval architects, I feel, and this I have faced myself, for a young budding naval architect who is coming out of college, when he sees opportunities with lucrative packages in, say, as we were discussing in the practice session in IT, so then he looks at the opportunities provided in the conventional naval architecture, he is kind of swayed away. But I would just put it to the young budding naval architects that what you see as a conventional jobs is just like the tip of the iceberg. Naval architecture jobs has, because of the relatively lower number of pass outs over which we have had, or alumni base that we have had, not all people know all the job profiles which are there to offer. What I would put to a young naval architect is, you are coming out with a shipping degree, and then you find out what you like within the realm of shipping, and you can specialize in anything. It need not just be a design consultancy or a shipyard or classification society, which most of them know of. It could be something like you could go and join the P&I clubs. You could delve into maritime law. You could start working with data and work towards the autonomous ships which are being built, which we are discussing today. You could work in the field of alternative fuels. You could also think of broadening your knowledge in the machinery aspects. I feel that there's a lot to offer in the operations profile. So a young budding naval architect should take keen interest, as Karthik sir was saying, not just limit himself to the hull design, but feel engineering in the true sense and delve himself completely into machinery design also. Know the complete details of the ship that you're putting in. So that would open the gamut of a lot of jobs. Like one conventional job could be a surveyor profile, wherein you survey even the machinery aspects, the electrical aspects, but you also could get into managing ships. The conventional roles which have been taken up by marine engineers is largely because of the ecosystem created because of more flow from the marine engineering fraternity. But if a naval architect pushes hard, there's no stopping. He should be able to crack all the leading shipping company roles also, and people have done that. Having said that, I myself am studying data, and I would put it to the coming up naval architect. If you feel really deeply about engineering in a true sense and you want to contribute, there's a lot to do within the realm of naval architecture, because you have an advantage. Advantage is that you get the skill set, let's say IT, and then you have the domain knowledge. Domain knowledge is not available with everyone. This will put you in a breed which is very, very rare to get for the companies. So you get the domain knowledge, and then you get the skill set, let's say in data or autonomous ships. This can put you in a project manager role, which could be lucrative, plus also very, very satisfying as far as the job is concerned. But having said that, so basically there is a lot to offer within the realm of naval architecture, not just looking at it in the conventional aspect. But having said that, one needs to be prepared for these kind of jobs. Reach out to people who have done such jobs. Maybe INA can contribute this by putting up something in, creating some sort of verticals. As in, if we have some naval architects working in the P&I clubs, we can, get a talk from them, and then, so that people know that these are also jobs to be done, maritime law or academics for that matter. So one has to be prepared as to how to get into these roles. So I think the most important thing is knowing that you are not limited by naval architecture. You can, like, for example, I'll give you a very simple example. Let's say you start designing a ship and you specialize in finite element analysis. So this knowledge of finite element analysis will not just is a cross-disciplinary knowledge. Tomorrow, if you want to get into, you can as well do that. So engineering is kind of very, very freely flowing. That barriers are not there. So do not have the mental barriers that to have. So you are looking at a ship, which is a complete form of engineering. Take out anything which interests you, and you will find out your way to excel in those fields. And I think as a forum at INA, we can we can, as I said, we can create verticals of all the conventional as well as non-conventional roles, because I think the only way to reach out for youngsters is through LinkedIn or through by knowing the alumni base. I think if we create those verticals and put up the profiles of people who have done that and get webinars or some kind of talks from them, it'll help them. So as I said, there you are at an advantage because you have a domain knowledge. So this will help you in excelling in the field. I think I am available for any personal reach out also. Largely, this is what I wanted to convey. One small part from the classification, because I representing the classifications also. So if you get into classification, you have a whole gamut of things to explore, right from plan appraisal to survey of ships to research and development. So there's so much for you to do that a short career span of 40 years will fall short. So do not lose out because most of us look at our alumni, near alumni, and we kind of don't get a broader sense of what is there to what this field has to offer. So have a broader sense of what you can do with this engineering and reach out to your seniors. I think that should be of good help. So that's it, sir. Thank you.
Thank you, Mr. Anil. Mr. Jathesh, is it okay with your audio and video that I can invite?
Yeah, I think I can. Yeah, you can hear me now, no?
Yeah. Oh, it's my privilege to introduce Mr. Jathesh Chandra, who is the Deputy General Manager at Cochin Shipyard, heading the Basin Design and Hull Structure Development Department. A naval architect with around 27 years of experience. He has his BTech degree in Naval Architecture and Shipbuilding from Cochin University and worked in the major companies, the NSDRC, then Hyundai Heavy Industries in Korea, Samsung Industries in Korea, M3 Energy FPS4 SDN in Kuala Lumpur, MISC SDN in Kuala Lumpur, TH Heavy Engineering in Malaysia, and after that he has joined Cochin Shipyard. Now he is leading a team of naval architects and design engineers and has experience in design, project management of various ships and offshore projects. Please give your perspective on the topics.
Yeah, thank you, Mr. Ankur. Am I audible?
Yes, sir. Clear, sir.
Thank you. Good evening, everyone. And first of all, I thank Institution of Naval Architects for giving me this opportunity to talk to mostly to students, and I consider it's a great opportunity as a naval architect to talk to the budding naval architects and guide them properly if that helps them. So, since most of them are maybe pioneer naval architects, I think there is no need to give much about what a naval architect is, but I would touch upon some of the recent aspects which have come into our compared to the classical naval architecture jobs which we were doing earlier, or which most of us, maybe including me, was doing. The new ships and the new technologies which has come up, we have to add on to the classical naval architecture, and the new technologies like digitization and data analytics and computational analysis like CFDs, computational fluid dynamics, FEA, and of course artificial intelligence. All these things we need to club together for the designing of the next generation ships. So this is going to be a very interesting field. So I can see a lot of these people who have done naval architecture has gone to ITs, but right now, even with if you stay in naval architecture, there is a lot of opportunities which can contribute to the marine structure or marine sector. So that way, the new technology, as you all know, the main challenge which we all are facing right now in the shipping industry is the search of an alternate fuel. That is, we are trying to see how to reduce the greenhouse gas emissions and protect our environment. So in this search, we are trying, and it's still a confused state. We do not know where we are going to and what is the future fuel. So right now we are trying out, in addition to the normal reduction in emissions, we are trying out hydrogen fuel cells, ammonia, then methanol. So all these battery and hybrid technologies, so all these are clubbing together with the naval architecture. It's going to be an interesting field for you to stay and work. And in addition to this, recently what has happened is with the growth of economy all around the world and the economic activities, what is happening around, shipbuilding and the need of transportation of goods through sea has uh, seen a tremendous increase in shipbuilding. And I have read it's going to be around 145 billion market economy for this 2023. And so shipbuilding is definitely going to be a very lucrative field for naval architecture, and especially with the new technologies, and it's going to be a very interesting and challenging field also. So that way, if you see the overall industry, you can see passenger ships mostly being constructed in Europe, but you can see the East Asian countries like Japan, China, and Korea. They are mostly into the merchant ships construction. Of course, China is the most now the leading nation having the maximum shipbuilding projects. So these are only for the shipbuilding part. If you look at, as I said, the alternate fuel, there is a development of wind and offshore market. Offshore wind has created a huge requirement of floating offshore platforms, floating wind turbines. There is a lot of opportunities for naval architects to look into it, like the mooring analysis for these kind of turbines floating in the offshore, and charging stations for the ships from the offshore field. Then the offshore industry itself, like the old offshore structures like jackups, then the fuel FPSOs, FSOs, semi-submersibles. These kind of structures are also going to be an area where naval architects has got a very, very interesting area to work on. The design of offshore structures compared to shipbuilding is totally different because it requires more customized solutions to the field of operation. So you have to really know the challenging and the existing environment in that sector and look at the loads, wind loads or the wave loads, and design the platform to be there for maybe 5, 10 or 20 years. So this is going to be very interesting and challenging. All sort of analysis will be there and construction. And these structures are going to be huge. Huge in the sense it may not be viable to construct in maybe an area where it is to be deployed, near to that area where it is to be deployed. So this needs transportation of these structures, huge structures from where it is constructed to where it is installed. So that means the transportation techniques, the transportation calculation using the heavy lift barges, which includes maybe the transporting companies. There is also a lot of opportunities for naval architects, transportation, sea fastening, how this is to be transported safely, and also how this is to be installed in the sea, maybe in a very very challenging environment. How this huge platform, which may be of the order of 10,000 or 20,000 or 30,000 tons, need to be lifted and put it on the sea, and it should stay there for 20 to 30 years. So that is going to be a really heavy engineering and challenging for the naval architects. So these are all ship construction or offshore construction field. Then there are loadouts and the heavy loadouts. These kind of things, these huge structures which are constructed in the shipyard or maybe the offshore yard need to be shifted to the transportation barge. That itself is an heavy engineering. So there also, and also the floating off of this platform. So this is going to be a really simulation work, lot of structural work. All these are the naval architect's role is very, very important, looking at the various sea loads and offshore environment. So these are globally a general thing which I have told about the naval architecture field. But in addition, if you see in India, the opportunities is growing tremendously. I think we are finding short of naval architects. We don't get very, very experienced people who can guide us in many of the operations of the shipbuilding requirements. So right now, India is the 5th largest economy in the world. And adding to that, we have got the vast coastline, which is around 7,500 kilometers of coastline. So all the reason we are going to grow as a marine leader, and shipbuilding will definitely improve. We have got around 38 shipyards, I think, in India. All of these are going to be seen in the coming future, in maybe next 4 or 5 years, because that much potential of construction activities are going to happen in India, and also the requirement all over the world. And if you see the government policy which has come in, and the promotion for shipbuilding in India, like the financial assistance policies, and also the policies which has the government implemented for the green ship construction policies, national hydrogen mission policies for promoting all over the production of hydrogen. So there is also a lot of fund kept aside for maritime sector. And also India has got vision called Maritime India Vision 2030, which is actually to boost the shipbuilding and the port sector and ship repair activities in India. So these are all together, you can see that all over the world, and looking at India also, it's a lucrative field for naval architects, and a challenging and interesting area to stay on. And if you think there is not enough chance outside, you have to have you should look at starting startups. India is the largest, one of the largest ecosystem where startups has become a very big success. So where you can see there are now the companies tying up with a lot of startups to get into and generate new designs, new technologies, and compete with the external other countries. So this is going to be another opportunity if you think you want to start your own business, your own design firms, or maybe research areas where you want to stay independent. And now coming to Cochin Shipyard, if you look at Cochin Shipyard itself, also we have done a lot of massive expansion projects right from new dry dock, in addition to the two dry dock which we have. New dry dock, which is around 310 meters, is aiming at max to a bigger jack-up rigs to be constructed there. And also, you have seen the aircraft carrier. There is a talk on the second aircraft carrier also. Then we have acquired other shipbuilding facilities in east and west coast of India, and also ship repair facilities in Andaman and Calcutta, and also in Cochin. So these are all, there will be requirement of new opportunities will be coming up, job opportunities will be there. So it's all the way, all the reason to say that the Cochin Shipyard also will be requiring a lot of people coming up. And you can see the recruitment advertisement coming up recently. Last year we have taken around 70 executive trainees. This year also we are taking. So it's going to be a lot of requirement in this area. And as I know, right now we have got IIT Kharagpur, IIT Chennai, and IMU, Andhra University, Cochin University, AMET has got, and SNGC Cochin. And also recently Christ College in Kerala also has started naval architecture. But I'm not sure how many of them are really staying in or continuing in this field. But looking at this, interesting and maybe the challenging and very lucrative environment outside, I would urge the naval architects to stay in the naval architecture field so that we, as India, we can contribute to the world and also to the marine sector in a very, very useful way. So, yeah, with that, I would conclude my talk for this session. Maybe I'll wait for the question and answer session.
Thank you, Mr. Jathesh Chandra. Now it's my privilege to introduce the panelist, Mr. Hariraj, who is General Manager, Smart Engineering and Design Solutions, India. He completed his BTech in Naval Architecture and Shipbuilding from CUSAT and joined GTR Campbell Marine Consultants with its Trader Series bulk carrier project at Cochin Shipyard. After 3 years with construction supervision and project management, he moved to Smart Engineering and Design Solutions Limited, SEDS, a sister company of GTRC. At SEDS, he has worked on design and development of various commercial and naval vessels, including ferries, general cargo vessels, bulk carriers, passenger vessels, petrol vessels, and corvettes. Hariraj is a member of the Indian Institute of Naval Architects, Royal Institute of Naval Architects, Lloyd's Registers South Asia Technical Committee, Class NKS India Technical Committee, DNV India Technical Committee, and the present Secretary of Indian Marine Designers Association. He can give a perspective on the design as well as design organizations. Please welcome, sir, and please give your appreciation and thoughts on the topic.
Thank you, Dr. Iyengar, and thanks to INA for this opportunity, especially the opportunity to talk to young naval architects who are coming to the field. As mentioned, I have been working with this organization, and when I finished in 2004, I wanted to work in a design company, and I wanted to work in India. I wanted to see how designs can be done here, can be developed here, and I was fortunate to get into this company who had, you align with the company, your thoughts, and then it becomes so interesting. And last 20 years, every day was interesting. I'm looking forward for tomorrow, because the way we have developed from what it was 20 years before and now, it's a sea of changes that I have seen. In the private sector, I'm from a private sector design company, and when we got into the market, there were very few designers, and the designers were mainly looking at designing of smaller vessels. There were no complex vessel designs, and in fact, the focus was not there. And we, as a company, because of the vision of our president, Mr. Anthony Prince, we wanted to bring this technology, we wanted to bring this capability to India. And now we have completed design for fast patrol vessels for the Indian Coast Guard. We have done designs for bulk carriers, and we have sat here and developed designs for handy-size bulk carriers and exported to other countries. Developed passenger vessel designs, very complex designs. Worked with Cochin Shipyard a lot, and now we are working on a corvette design, which has some of the most complex requirements that we see as naval architects. And so it has been exciting, but the time has never been exciting as it is now, because actually we are wondering what to do with the amount of opportunities that is glaring at us and glaring at India. Because I always have this thought that every young naval architect, when you look at your career, you should try to align it with the vision of the country, because the country has invested in you, expecting that you will take the country forward. And now you are coming to the industry, an industry which has been noted by the leadership as one of the major industries that will take India forward. The policies are slowly, I think, developing in the right direction. Our capability is nothing. Our capability is nothing compared to what is required to meet the demand of the present global demand of shipping or ship design or shipbuilding. So in this context, I have tried to make a small presentation. I will share it, and I'll go through the thought process strictly from design point of view, and that too I would again would like to say an Indian ship design and Indian industry point of view. I hope my screen is visible.
Yes, your screen is visible.
Yes, thank you. So this in the screen, I have kept an image of a passenger vessel, a 500 passenger vessel built by Cochin Shipyard, being operated in Andaman and Nicobar area, where I just try to keep various aspects that as a naval architect we do. Starting from initial hull form design, understanding the weight and weight management, doing design development of structure and outfitting and all other aspects. Styling, which we practically lack. We are so far behind many countries when it comes to that, but which is also very important, and many aspects. And as a naval architect, like Ankur already mentioned, you can get into any of these areas, and the requirements are abundant. So I try to keep the content into three major groups. One is major drivers for the industry. What does it mean for designer and it's each one of you, and the need for the hour, which we see as a company and I feel as a person. So the major drivers, as Mr. Girish also mentioned, and everybody in fact mentioned, it's the sustainable development. That is, we try to develop with clear view of our future generation, that we should leave this earth, the nature, for the future generation. And I don't know whether you understand or not, as ship designers, we play a huge role. The ships are transporting 90% of cargo, and in 2050 there will be at least 2 or 2.5 times of cargo movement, and you're looking at maybe 150-200,000 ships operating in the globe. So we play a very important role when it comes to this target. Decarbonization and digitization, these are the three major areas which will drive the industry as we move forward. And this, when we talk about designers, this, as I told, the world fleet has to be renewed in the next 30 years. There is no choice. None of the vessels which are operating now will probably meet even requirements in 2035. So we are looking at replacing the entire set of vessels operating now and designing vessels which we really don't know how to design. We know there are options, there are many possibilities, but with certainty we don't have an answer for what the vessel will be in 2050. In this context, I would urge every one of you to read future predictions from different classification societies, International Association of Renewable Energy and all, which will give you a clear perspective of how the industries see how we will look to the future. The design targets are becoming more and more stringent. Like I was involved in a design of a handy-size bulk carrier 20 years before, where we had a 30,000 ton bulk carrier with a 5,600 kilowatt of CSR power, which was the best, which it was considered as the best in the market. We built 65 ships for our various clients. And now a 30 or 42,000 vessel, if I go with 5,600 kilowatt, that is, if I have almost 30% more dead weight, and if I try to keep the same power, I don't even stand a chance to talk to customers. People are looking at 4,800 kilowatt for a 42,000 kilowatt vessel, 42,000 deadweight vessel. That is just from the powering point of view. There are many other aspects: emission, ergonomics, the noise and vibration aspects. So many aspects which have gotten attention much more than what it used to be before. Extensive use of design optimization and advanced analysis, which I have put some slides to discuss. We used to, from what it used to be an empirical approach to what is goal-based approach now, the change is phenomenal. And we as a country, we are blessed with brain power. We do have certain issues, which also I will mention, but these are areas which, when I speak to many clients, many designers outside, I feel our comprehensive understanding on subjects are way more than what we judge ourselves with. So we have a lot of opportunity when it comes to complex mathematical problems, complex design issues, and we should really understand it and try to capitalize on our capabilities. Alternate fuels and propulsion, which will have the major focus in the coming few years for sure, till we really find the right combination or right solution for design consideration. But this alternate fuel itself has considerably changed how we will look at commercial ship designs. Then there are many new technologies. I've tried to list a few of them, and a generation of many new types of cargoes, which will be aligned with the development of decarbonization and alternate fuels as we move forward. So the world fleet, I took it from UN Review of Maritime Transport. There are about 105,000 vessels, 40 to 50,000 of large commercial vessels. And this has to double, or maybe even more than double, maybe 2.5 times in another 30 years. And every one of these vessels are to be replaced. So that is the market. So as a country or as a person, when you look at, that is a market in which you are going to get in, and probably you're going to work throughout your career. So you really don't have to worry about jobs or what you would do. You just have to think about what exactly you want to do in this sea of opportunities, as mentioned before. The stringent design targets, as mentioned, the CO2 emission reduction per ton mile of cargo transported, which is basically the last thing that you see. But identifying it and trying to design for it, it's a real challenge, very interesting challenge. And every time we can always come up with the best solution, but it has to be cost effective, because whatever you do with shipping or ship design or shipbuilding, it is finally paid by the end user, the customer. That is each one of us. When you buy something from the supermarket, in some way the shipping is involved. So whatever cost that is going up, it is controlled by the whole market economics. So we have to really understand. So we cannot really put what we think is the best, what the market can pay. So it's a bit complicated scenario now, which I feel will be clear more and more as we move forward. Reduction of all other emissions, whether it is nitrous oxide, sulfur dioxide, particulate matters, methane, methane. All these emissions are now seen in with a magnifying glass. Sometimes I felt, why are we worrying so much about shipping? We just emit 3% of global emission, transporting 90% of cargo. So why don't you just leave shipping and try to focus on land-based and power generation and steel and other industries? And we can look at shipping when everybody has found the best solution and try to integrate the last, to shipping. But probably that is not the way we are going ahead. We have very clear targets. In fact, IMO has revised the deadline to net zero by 2050, which is a very stringent target. Hope we will see that, and it is going to be really interesting. And maximizing cargo capacity and internal volume. It is every time people want to reduce steel, increase capacity, because ships are being built to transport cargos. So when the person who is spending his huge amount of money, he wants to see how every inch of every cubic meter can be increased in the cargo capacity and increase the transportation that he can do with the ship. Identifying optimum endurance. This is more important when we are talking about future fuels. Any of the future fuel we are talking about, whether it is hydrogen, methanol, ammonia, these are all having much lesser, lower calorific value. So to get an equivalent endurance, which we say the distance that a ship can travel with a single bunkering, if we have to maintain same as our standard fuel of HFO or LSHFO, you need at least 2 to 2.5 times or 3 times volume and weight for the fuel. And as I said, the ships are not built to carry fuel. We need to really identify how much fuel you will carry, depending on which fuel you want to design your vessel for. This will also depend on how the industry, bunkering industry will develop, and so many other industries will develop. So as designers, this is a major question that we will have to ask the end user. I know how much you want to sail with single bunker. The optimization of capex and opex, the capital expenditure and operational expenditure. The operational expenditure in the last 1 year or 2 years, people have really started seeing, how we really optimize. They say easily you can optimize 30 to 35% of your cost for shipping just by optimizing the operational aspects. There are many companies working on it, starting from voyage optimization, your fuel optimization, the speed optimization, and even the people optimization and all those things. It's a huge market. So many development happening in that area. Crew comfort and habitability. There are regulatory improvements that is happening when it comes to noise and vibration aspects. In addition to that, shipping is not it's a dirty industry. It's not like as lucrative as software or many other industries. So we need to get good people to shipping and shipbuilding and ship design and ship operation, the comfort and habitability aspects are to increase, the safety aspects are to increase. So that is also a design challenge that we see as we look at it. Then reduction of UR and underwater radiated noise, which is already there. We are discussing. In fact, India is part of Glow Noise project, the global project where we as a company are also part of it. We feel this is going to be another major aspect. When you design, you have to really consider underwater radiated noise. Already ports in Canada like Vancouver are giving you certain benefits if the vessel is designed meeting certain underwater radiated noise requirement, especially looking at the killer whale population in the Southern Ocean region. So there are these are things which are creating a lot of new interesting areas for each of you. And of course, safety. Whatever we do with all these aspects, the safety is predominant. Whenever a sailor, a marine engineer, or anybody is going on board, he and his family is hoping that the designers have done a good job, the builders have done a good job, and made a safe vessel for him to sail and operate. So it is our responsibility in whatever we do, keep safety first. And the safety considerations have considerably changed, whether it is with the amount of fuel, alternate fuel that we carry, or the optimization that we do. Sometimes people optimize it so to the core that you are hardly left with any margin for extreme weather conditions. And there have been many cases of power optimization, because in the from 2010 to 2016-17, all the major sail like ship sails happened with optimized power. So everybody were derating engines so much that to show you have only minimum power. So there are many ships with huge engines derated to so low power, just to show that I only need this much power. But in heavy weather, the ship is sitting duck. It is not having enough power to push it through to the seas. You can just go to YouTube and see how a harsh weather will look for a large ship. And we are designing a ship to sustain those kind of conditions. So we have to educate the end users when it comes to to what point the optimization can go. And extensive use of design optimization and advanced analysis. I have already covered this in various aspects when it comes to CFD, because in 2010, if we were to optimize, say, a multi-point optimization for hull form, each run and software would have taken us a week, which hardly takes an hour now with the computation capacity and the software optimization that is there. So the flexibility or the flexibility that the designer has with optimization has increased considerably, along with the amount of information available. 15 years ago, you search Google, you get some minimum information about topics. But now, whatever is the information that you require, it is available to a large extent. So you can actually digest a lot more than what you could do 10 years before. So as a budding naval architect, your availability of information is plenty, but understanding what is right and of course what is required is critical. That's for which you should make use of senior people, industry people, call industry people to come to your colleges and talk, which will really help you to understand, how you should look at things. The propeller efficiency and propulsion system, there are so many design improvements happening in that area. Minor 3%, 2%, 5%, but there are lots of work going in that area. FEA, I've mentioned it. It is also there in other industries, but I'm focusing on ships. Then the design approach itself. Now, most of the designers are working with 3D as the design basis. Like earlier, there used to be a flow of your concept design, and you do a contract design, and you do basic design, basically a desktop design, and then you develop a 3D model for your production documentation or detail engineering or production design. But like in our company, all the designs we start with 3D model. It's not. It gives a much better perspective for designer, the end user, the shipyard, when it comes to not just design, but buildability, operability, safety, accessibility. These are all important. And with the use of VR and AR, the end user gets a real feel of what he is going to get or what he would like to see in his ship. And that is, it's an amazing tool. And of course, it requires much more effort at an early stage of design, but that effort is well worth spending, because the cost that you save in the whole shipbuilding, you take shipbuilding is a minimum, let's say 20 to 30 months process, depending on the complex nature of vessel that you're looking at. And in the whole process, the design cost may be like 1% or 2%, which used to be 5% and all. When I study, I remember people talking about 5% for total design and all, which has drastically come down, which is also one point I want to mention towards the end. But that is where you should spend properly, so that you will have smooth building, smooth understanding of what you are going to get, so that you avoid confusions, you avoid changes at later part of design. And finally, for a shipyard, the real profit that you make from shipbuilding is by early delivery. You deliver 1 month ahead of time, you really make a profit, because you can only get what the market pays. And if China is paying, delivery is promising $20 million for a ship, nobody is going to give us 25 million, and they will not come to India to build a ship. So we will have to find a way to do it in 20 million and make some profit out of it. So the only way to do it is spend on design, optimize your processes, and do an early delivery. And that is where each one of the naval architect can really contribute to the industry. And alternate fuels, everybody has told. I mean, this is one of our LNG fueled bulk carrier designs, where you can see, I mean, we wouldn't have even expected or thought of this kind of a fuel system for a bulk carrier 15 years ago. This we did in 2014, where one of our clients wanted a large group of vessels to be operated on LNG between US and Europe. Imagine a bulk carrier having so much LNG on board. So you need crew training, which becomes much more than what it used to be for a dry bulk cargo vessel, and a lot of additional systems which are to be maintained by the crew. So the amount of training required has increased. And as designers, when we think of keeping fuel like this, and you can imagine the fuel reducing, and you create a lot of sloshing forces much higher on a ship, which never used to be a design consideration before. So when you talk about seakeeping or maneuvering characteristic of a ship, your disturbing moments are much more than what it used to be before. And it is the same when you talk about hydrogen or methanol, because of the characteristic of the fuel and the way you have to combine these fuel and try to keep it in one tank. That is increasing the amount of disturbances that the fuel can actually have on the ship when it comes to its hydrodynamic characteristics. So as designers, the amount of focus that we have to give on these aspects have increased compared to what it used to be before. And another clear aspect is alternate propulsion systems. Diesel electric is clearly getting much more attention than what it used to be before, because it gives much better control over operational optimization of your power. It is not you will never see a direct comparison, because again, 10 years before, a ship's fuel consumption is told at your whatever sea trial power that you get, CSR power, and that is for which you calculate your daily fuel oil consumption, and you make a statement. But now you're looking at how you operate the vessel for the next 15 years, 10 years, 5 years. Then when you look at your overall operational characteristic, and you see, how much ballast voyage you have, how much loaded voyage you have, where you will be operating, and then this kind of a system with multiple energy sources, better control on your efficiency, your power management, it gives certain advantage. So though it is more expensive in the beginning, it will become much more attractive at later stages. And this is also important when we see some of the development that are happening, especially when it comes to fuel cells and battery hybrid. Even if there are some owners who don't want to go for the fuel cell now, he can better integrate to his vessel later stages, these kind of technologies, if he has a diesel electric grid other than a conventional propulsion. So when we look at a design, instead of just being driven by conventional methodologies, you have to really think what will be the best, considering various operational aspects that the vessel will be going through. And nuclear is, I have a lot of interest in this one, because the amount of interest that the market has on nuclear has increased considerably. Of course, it is a huge policy related matters now. Already there in the world, there are many areas where a nuclear power ship cannot go. But with the kind of developments, and if you really follow it closely, you will understand it has immense potential. And this is a true kind of green solution. And interestingly, if we look at our ships that are operating, almost 85% of emission are coming from 15 to 20% of vessels in operation. It's not the 100 full ship that we are concerned. Our major emission is coming from huge vessels, huge containers, huge tankers, huge bulk carriers, which are actually about 15 to 20% of your total fleet. And when you look at those kind of vessels, and when you look at their lifespan of 15 or 20 years, we can really think of alternate financial models, alternate models in which these ships can be designed with nuclear propulsion, and large companies are investing, like Microsoft and many others. So I hope we will see this commercial ships with new. It's not new, people have done it before, but there are a lot of concerns which are being attended, and I believe this will be a design alternate for us, and many of us might see it. And there are many other technologies in the market, like in the naval architecture perspective, when we look at starting from powering, how you reduce the drag, air bubbling system, low friction coating, and even coating that reduce the underwater radiated noise. The shaping of superstructure, it probably contribute to 2% of your resistance, but people are even concerned about it. People can really, if you can save few 0.2% from it, still it is interesting when you look at 20 years of your ship's life, or 25 years of your ship's life. The thrust deduction with wind sails, which has gotten a lot of interest. Just 1 year before, the presentation told you need say 9 to 10 years to get your return on investment with any of these wind sails or rotor sail installation. But now, with all this carbon taxing and other industry measures that are happening, probably this will be 3 to 4 years or 2 to 3 years to get back your return on investment in certain routes. So when we look at design, we have to really see whether these things are going to be option for you in your designs. And reducing heat losses and autonomous operation definitely will change the way we design, because this will be, I think this has more impact on naval vessels, Like we did a study for one of our designs. We felt you can actually reduce the ships to 25 to 30% of its existing size, meeting all the goals, because a naval vessel is always designed for a mission. So if a mission is for submarine hunting or mine hunting or whatever, if it is a frigate, there are certain mission defined. And even now we are spending so much area and volume and weight for the safety and operation of crew. And just imagine if you can remove that part, you can still meet your requirement with 30-35% of your vessel, and you save, people can operate safely from the shore. So you are actually saving a lot of lives, or saving risk of from the lot of lives, and cost is much less. So we feel it will be a huge area of development, especially when it comes to naval vessels, but also to some extent for commercial vessels. And generation of new cargoes and vessel types. We feel it has a very interesting aspect, because you might have heard about carbon capture, which is one of the technologies which are happening. So all this captured carbon requires some ships to carry it from point A to point B. The hydrogen is becoming a fuel. You need liquid hydrogen carriers to carry hydrogen around. You need more bunkering vessels for methanol, ammonia, hydrogen. You need windmill. The wind is developing huge. In fact, what I have kept here is one of the proposals we made for one of our client. This is for a future development. So it's one of the developments where they need to transport 165 numbers of windmill blade. And then initially when the query came, we wondered, why? Okay, 165 doesn't look like a big number, but they wanted to carry 165 of this windmills with a one blade length of 125 meters, the nacelle of about 1,000 tons, the tower which high is about 90 meters. So just one windmill weighing about 3,000 tons. So what it has to be carried in a ship, and which ship? There are no ships to carry those kind of of products. And the way the wind is going to play a role, and offshore wind is going to play a role in our future energy mix, we feel there is a tremendous amount of requirement that are going to come when it comes to these kind of vessels. So, okay, these are all the opportunities, but how do we look at it and how do we make use of it? So we have to prepare for the surge, and each of you have to prepare for the surge, understanding the market, and training and skill development is essential. As a small company, we find it very difficult to get people and to retain people, because as I told, it is somewhat kind of a personal interest that I feel we have to align ourselves to our country, and I feel you should not be just driven by direct personal benefit on short term. You should look at long term, and right now, because it is also connected to the remuneration and how you will see the industry when you just come out, when you compare with your peers and people working outside. Right now, the industry cannot really pay. I feel what industry cannot pay what you really deserve, or what a naval architect really deserve. It is because of a very difficult market that we have created with the kind of procurement system we have, and with a lot of restrictions. But I am seeing, as a person in the last 20 years, I'm seeing constant improvement in that area. And we cannot really develop with that kind of a mindset. So I believe that is going to change. You have to be patient, but you have to really invest your time and effort here, because India is probably one of the major solutions for the entire globe, because of geopolitical reason, because of many other developments that are happening. A large mass of this requirement of future ships are to be done in India. So whether you are a designer or a builder or anybody, we have to, first of all these industries have to work together, and it is a huge opportunity that is waiting for us. And we have to identify these working groups, which is very important, because we are still working in islands. If you compare the research and development that is happening in Europe and us, I mean, there is no comparison. You cannot even put 1 point against 100 for us. We are that behind. But I feel that's okay. We cannot really worry about looking at the gap. We can always start, and it is essential that we start. And this is a good panel where we have representatives from various industries. I feel Cochin Shipyard can take a huge leadership role, and IRS. These are two large institutes in India, which I believe should take the leadership role in pulling the industry together, whether it is about research, whether it is about training, or whether it is about really putting a benchmark. If you know, a European decent designer, when they charge 100 or 150 or 200 euros per hour for a naval architect, in India, you cannot even charge $20. That is how we have pushed down our industry. It's not that we are not capable or we don't have the skills. It is just, I think we have pushed us down too much, and we have to find a way to really revive this situation. If we don't do that, the worst thing that is happening is we are not able to retain the skill. Like the best, we should be able to retain the best naval architect in the country who are coming out, the top 20%, not the last 20%. So if you really want to look at that industry, it is your patriotism, your focus, everything is important, and we industry also have to play a large role. I feel it's not a it's not a comment to the audience, it is basically a comment to the panelists. So that is that's what I wanted to say. Thank you so much for the time. I'll stop the presentation. Thank you.
Thank you, sir. Before I move into the final comments of the chief guest, Mr. Girish, I would, with his permission, I would like to add a few thoughts on what is happening in the research, particularly academic research. I actually thought I'll not talk much on the research topic. I just thought I'll just only be the host and not talk. But somehow I felt that when we are all talking and all the eminent panelists have given their viewpoints, I found that this is something which probably because of my job profile and my interaction with academic institutions, I may just be able to offer a ringside view of what is happening in academic research. For academic research career, when it comes to research in India, apart from the industrial research point, where Mr. Girish is going to probably highlight, or he had already told about the industrial research. Mr. Hariraj has talked about the industrial research, and Mr. Chandra has talked about the industrial research. When it comes to the other part of R&D, mostly it is basically government research institutions, where the entry level is basically at graduation. But since they are government research institutions, you have to just wait for the government advertisements, and if the advertisements come at the right time, you join the institutions. And sometimes there are lateral entries, and so even recently also there's a lateral entry for government institutions to join at lateral entry level at varying experience of 4 to 15 years. Recently also there's an advertisement. So there you can join the government institutions, research institutions. But when it comes to academic research, the minimum requirement is a PhD and a postdoc. I've seen in the audience some of my mentors and advisors, very senior professors who are in the audience. So they'll also agree by telling that you need a reasonably good PhD, reasonably good publications, and a postdoc before you enter the actual formal academic career. Having said that, the sort of problems which thankfully for me, Mr. Hariraj and Mr. Jathesh and Mr. Anil are nicely brought out, is that the sort of problems which 2 decades back was probably academic research. For example, something like advanced hull forms or those CFD codes or the industrial, they are all now basically become industrial standards. So when we talk about academic research, we are just talking about those topics which probably will get into the industry, maybe at least 3-4 years down the line, if not a decade down the line. So in that regard, now if you see, the sort of academic problems are mostly both in experiments. Today, both in IIT Madras and IIT Kharagpur, there is a very huge capital expenditure which is being incurred to construct a seakeeping and maneuvering basin. IIT Madras is almost over, IIT Kharagpur is on the way, and in a couple of years it will be ready, which will give a huge input or huge impetus for academic research, because otherwise these facilities are available only with DRDO. So that should promote a lot of experimental research. And the sort of problems that we are working in academic research is mostly related to computational fluid dynamics, two-phase flows particularly, because as we know, both from cavitation point of view and from free surface point of view, two-phase flow. And increasingly, we are going into high-performance computing because we are just talking about not the sort of, say, 20 cores or 30 cores, which, as Mr. Hariraj just told, that is already available in the industry and they're comfortably handling it. We are talking about problems which actually require me to handle, say, 1,000 cores running for 1 week sort of physics problems. Those are sort of problems that we are working in the academic and this thing. And the parallel computing facilities at various academic institutions, research institutions are being used for those sort of problems. What are those problems? They are primarily centered around propeller acoustics, including the complete full-scale hull form. We are no longer talking about model-scale hull form. The full hull form, 100-meter hull, where the grid size is going to vary at a very micro level near the boundary layer to the coast level with unstructured grid, propeller acoustics and its hull impact and all those things. These are the sort of problems that we are talking, where we are operating up to the cavitation region with cavitation also coming into the play. That is what is calling for two-phase flow, including bubble collapse and those mechanisms. Experiments are also being done in those regions. The other region where there's a very good academic research which is happening, and that's not just in naval architecture departments, but mechanical engine departments across the country, is related to structure-borne and airborne noise. He was talking about underwater radiated noise. We are also having a lot of mathematical models regarding structure-borne and airborne noise is also being researched, not only in the naval architecture departments, also the mechanical engineering departments across the country. When it comes to the whole vehicle itself, now there's a general trend. 10 years back, a lot of academic institutions were working on autonomous underwater vehicles and autonomous surface vehicles. Mostly those vehicles have now been tied up with the industry and they're getting converted to industrial product. However, when it comes to vehicle autonomy, still there are a lot of academic problems which are still there. For example, path optimization, where I include the environmental model also, so that the path planning can be done more efficiently during the deployment, so that either it's an energy optimized path or a time optimized path during each missions. Then we also have the guidance and navigation, more advanced guidance and navigation algorithms. We are no longer talking about simple sliding mode or PID, but more and more advanced algorithms with guidance. And the third thing is about basically localization and working on the observability matrix. Localization is about knowing where you are, and particularly when you are increasingly operating in regions where the GPS signal is limited or the communicational bandwidth is limited. That is the area where how accurately we are able to localize and know where my ship is relative to other ships. And the problem is more acute in the case of underwater vehicles where GPS is not available and communications are also, bandwidth is also very limited because you have to rely only on a first communication. That comes to the other problem of observability. Normally, when I work on land robots, I have the odometry whereby monitoring the vehicle wheel RPM, I can just get the position of the vehicle in some sense. But in the case of ships, it's mostly propeller. And the relationship between propeller RPM and the distance that we move is not so direct. All of us know about the extensive propeller theory with whatever assumptions we make, whether it's linear or non-linear. So in that sense, to what extent can we build up the dead reckoning to advanced observability matrix when our sensor performance is very limited? So these are all the other areas that are of very active research, particularly when we translate into a very useful, cost-effective product. Because it is always possible for us to use an inertial navigation system is very, very costly. Of course, we are using it in some platforms where the cost of the platform is so huge that the sensor cost is a very minor consideration. But as we go into smaller and smaller autonomous vehicles, the cost of the sensor itself will be the major cost component. So we have to have a group of sensors and sensor integration with which we are able to get the sort of navigational accuracies which is demanded for the performance. This is a very active research area, particularly in the autonomy from the academic research point of view. And another major research that we are trying to do is to learn from nature. So biorobotics is started in a big way in the country. 3 leading academic institutions are right now working on a biorobot, which will help us to understand biomimetic propulsion. And later we will also migrate into biomimetic sensors. When I tell biomimetic sensor, we are trying to model the entire gravity wave, that is the pressure wave, which is going to be felt by the sensor. And that physics is supposed to be completely studied and identified, which will help us in identifying what are the obstacles before me and probably classifying the sort of obstacles. So that is the other area that is a very active academic research for autonomous vehicles. And at a purely personal note, there was some talk about the monetary aspects of it. Long back, when I had probably spent about a decade of, experience in R&D, there used to be students who just come to our model testing agency for their model testing orientation. That time, the same question was posed to me. I just told, probably once a month I can afford to take my wife for a good dinner and enjoy, and that's it. So that's the sort of salaries. Probably I cannot do it maybe every weekend, but I can certainly do it once a month. And otherwise, I have a decent small car, not certainly an Audi, but a decent small car, and that is it. And I have a comfortable life. But the sort of R&D funding that I'm getting, both from academics, I know that, for a very good and well-defined project is almost unlimited in this country, considering the sort of support which government policies are giving. For R&D, for the right problem, cost is not a constraint. So in that sense, an academic institution, a person who is working or connected with an academic institution has a good idea. There are various forums, whether it is being from the Science and Technology, Ministry of Science and Technology, or from the Naval Research Board. There are various forums where academic research is being supported and funded very, very well. And the cost is not a constraint. The cost is dependent on the problem. So cost is not a constraint there when we consider the monetary aspect. Of course, from the personal monetary aspects, Mr. Hariraj has very rightly told about we have to sustain. And in a few years, of course, we'll see the change. But it is not as bad as it used to be when I first came out in 1999. The situation is much improved. Naval architects are at least paid very decently compared to when we have to, say, 4 people have to stay a room in Bombay. At least those situations are no longer there, as Mr. Girish or Mr. Dasgupta will tell. Those situations are no longer there. We are comfortably, decently starting our career. Not as much as maybe some other professions, but our start is decent. And yes, it's only in comparison it is inadequate, but overall it's a decent personal monetary thing also. With these few comments on vehicle autonomy and structure-borne noise and high-performance computing, these are all the different areas in which academic institutions are working and R&D sector is working. Apart from the standard industrial research regarding hull forms and energy-saving devices, which has already been talked by my co-panelists. With this small, say perhaps peep into the academics inside view, now I would request the chief guest to inform his thoughts and then your time to use. Thank you.
Thank you, Dr. Iyengar. Yeah, firstly, I would like to thank all the panelists for giving insights into the various aspects, various opportunities, and but through that we have got into other areas like the design and what all things can be done in this country to improve things. All such areas we have covered, and I think the students would have got a very broad idea of what all things are possible, and it's not, and definitely they will feel that okay, this is a field where all kinds of opportunities are there, and even we also talked about some of the monetary benefits also, and it's not as bad as it was probably here, and things have improved quite a lot. Commander Karthik Das, he talked about the Navy and the experience, the lot of practical exposure and experience what you get in the Navy, and especially Navy is dealing with right from design and construction to operations of the vessel. They have got a very wide exposure to various aspects, and which will be definitely of interest to students who want to take that kind of a career. And then Ankur talked about the classification and what are the kind of work what we do in classification. And also he highlighted one point it's of interest, that the naval architecture is a complete complete engineering package. It's not just one branch of engineering alone. It has got the complete system in place so that you get the benefit of working in various fields of engineering by being in naval architecture. And the holistic approach, people who are interested in seeing that kind of a systemic or holistic approach, they'll find it very interesting to work in this field. And Jathesh Chandra highlighted what are the new challenges, what they are facing. And Cochin Shipyard is having a lot of opportunities, as we understand from him. And they are also spreading. There are going shipyards all over now, and a lot of. He also talked about the offshore construction challenges, which may be of interest to those students who would like to go into the offshore field. And lastly, Hariraj was talking about, he gave a very detailed presentation. I appreciate him for making this very detailed presentation, giving all the aspects, covering various aspects, and going into so much of the function of each item, like he started with sustainable development, decarbonization, digitalization, and went into the detail of every aspect. Some of the interesting points like alternative fuels. He also talked about the training of crew. In fact, that is some of the things that the ship owners will be interested. Otherwise, there need to be somebody who can run this ship safely. And finally, he talked about he referred to the nuclear power ship. In fact, we hear that this is something being thought about, and there are secretly at least many countries such work is going on to use nuclear power ships. So we definitely will see this potential being fructified. Because he also indicated something about the joint industry projects, which is a way forward for anything to be done. Just one organization or one design company alone will not be able to do anything. So we need to have joint industry project. In fact, we already have certain projects between CSL and IRS. And like that, we can include more stakeholders and have joint industry projects. And that is the only way it should include research, design, construction, shipyards, as well as the class societies together. If you start working on a project, then it can reach a level where you can say the design will be more or less practical, and it can be approved in principle by class also. So such activities are being done in other countries, which we have got much less of activity. That is where he has highlighted that this requires a lot of improvement. And lastly, Dr. Iyengar talked about research. Of course, he talked about high-end research, whatever is happening, and some of which are entirely new things we have not even heard of. Of course, it's a how to apply it to our industry. We have to still not come to a stage where we can apply it at the high-end research stage, very high-level stage. But one thing he pointed out that there is a lot of limitless funding for R&D, good R&D in this country. It's always promoted. So that means if you are planning to do work in research, definitely you can be assured that if you have good R&D projects, it will be funded. So coming to, so I think with all these insights given by the various panelists, I hope our students who are getting into this field would now realize the opportunities, and I would urge them to stick to this field and learn and grow with this field. We are going through a very challenging period where a lot of things are happening: digitalization, decarbonization, especially decarbonization. IMO has already decided the strategy. In 2023, they have decided for net zero by 2050. It's a very ambitious goal, which definitely, but the way things are happening outside in India, and a lot of designs are being developed, and new engines are being developed with the new alternative fuels and all. So a lot of testing is being, in fact, we saw that a lot of testing is being carried out for using ammonia fueled engines. Probably it'll maybe, I think, within 1 year we may have working ammonia fueled engine. Like that, we already have designs for hydrogen fuel cells vessels, smaller vessels, battery powered trucks. That is something which the Indian government is also thinking of introducing in all the ports. Cochin Shipyard is involved in this design of such vessels. They will be in fact, recently we had the Global Maritime India Summit where a lot of MOUs were signed with Cochin Shipyard and various port trusts for building such stuff. So there are things happening in India now. It is not it's not like earlier days, but with this new decarbonization, digitalization age coming in, India is also going ahead, and with the demand for shipbuilding all over, definitely India also will have a lot of potential for building ships, and which means that a lot of jobs for our young naval architects and a good career ahead. So thank you. I think that's all I would like to summarize. I think maybe we can go for question and answers.
Thank you, sir. Perhaps now we will take a few questions. Some of the questions were on internship that I'll just address separately. Perhaps one interesting question which has come from Mr. Tulala Sai Chandan is what might be the weightage for software studies like AutoCAD, Delft Ship, etc. for the future? So these added skills, how relevant is it? Is the question of Mr. Tulala Sai Chandan. So perhaps from the shipyard, probably Mr. Jathesh can probably throw some light on this question, sir. How or
If
Mr.
I can,
Hariraj, one of them. Yeah,
can,
one of them.
answer
Yeah.
it to some extent.
Yeah, please.
I feel like I studied in Cochin University, my naval architecture, and I believe I use everything, whatever I have studied. In fact, I have not studied anything more than what I studied from QSAT. So the base was well set. We had, whether it is structure, whether it is thermodynamics, whether it is stability, resistance and powering, the shipbuilding, it's a very conventional thing. So even if we are talking about new future, it's developing on the base. So the base is to be very strong. So your technical understanding and understanding of the subject is very strong. It has to be very strong. All the software over the last, whatever I have seen over the last 20 years, the usage, the ease of learning has improved considerably. So for a student who is completing his any engineering in a reasonably well way, I think it takes two weeks to study any of these tools. So of course it is a good skill set to have if you have learned some software. But from a company perspective, if you are interviewing a student, his understanding of software is probably the last thing that we will see. Most important is whether he understands what he has to do when it comes to the subject. And teaching him software would definitely take time, but it would take, like as I said, 2 to 4 weeks for most of the tools that are normally used in the industry. This is what I feel.
So
But
anybody
yeah,
else wants to add
I would
something also?
like to add there that yeah, because I think without AutoCAD and software, now there is no naval architecture also, because we are doing all these computational. We need to do this in using computers. So yeah, of course, you should know the basics, because hydrostatics and line span, unless I don't know whether now people are doing that way where we used to do with the baton, but they are doing in pairing in AutoCAD painting directly. And even using calculators are there. I do not know for hydrostatics. Maybe it's directly on the Excel. So it's changing. So it's definitely, this is what he has asked. AutoCAD, Ship or other softwares is a must. Subject knowledge is basic, but this is also a must now for going ahead if you want to do in real naval architecture.
Sir, I've just put this thing in a very lighter note. 20 years back, when I was trying to prepare my resume for companies, I used to write the skills that I know is AutoCAD or some such similar skills. But as Mr. Hariraj just told, if I write that, that is no longer considered a special skill. It is considered something that I should anyway be knowing as a part of my naval architectural knowledge. So some of the things which were considered specialized skills 20 years back, or 10 years back for that matter, is now considered something that we should be knowing as a part of our soft skills, if not as a formal curriculum. Perhaps that's my this thing. So yes, certainly we should know all these softwares. They are very useful. There are more specialized softwares for ship resistance, ship flow, and all those things. But as Mr. Hariraj just told, all that it takes is probably 2 weeks of training into any of the softwares, provided we thoroughly understand the basics. A. And B is, some of these things even are considered something that we are anyway supposed to know by the time we enter the degree, and they are not no longer considered a specialized skill. At least standard softwares like AutoCAD or any of those hydrostatics softwares. This is my thought on the topic.
I also agree with that. AutoCAD, you don't really consider as a software.
Yeah. Or for that matter, any of the 3D modeling softwares also. So with that, probably that will add this thing. If any other panelist wants to add a thought on this, any other panelist want to add to this? Otherwise, I'll go to the next thought. There are at least 3 questions basically on either apprenticeship or internships. I am sure I can talk on behalf of all the organizations here that certainly, yes, summer internships all the organizations do take. They have their own ways of taking that.
Hello.
Yes, sir.
Hello.
Beg your pardon, sir?
Can you hear me?
Yes, sir. But only thing is we would request, at least if you talk in terms
Hello?
of, hello, am I audible? Hello? Yeah. When it comes to internships, all the organizations do take summer internships, 2 months to 3 months according to academic requirement. Only thing is your faculty has to write to those organizations. You are the faculty coordinator. And then that is how internships are generally handled, not at a probably personal level. If each organization has its own policy as to how they'll take the internships and how many interns they take and all those things. But in general, yes, internship opportunities are available across wherever you want to. There I leave the questions on internships and also a very similar question on university entry scheme, unless some other panel wants to add something to this.
Yeah, I can add on here. I think in Cochin Shipyard, if you want to apply for internship or apprentice training, you have to register in a site called NATAS. That means National Apprentice Training Scheme, where you can go and register and you can give choice preference in Cochin Shipyard. So we'll take depending upon the requirement from there. So I think students can take a note of that. And now we have called for apprentice trainees in naval architecture also. And in addition, we also doing means guidance for project works. Like if you want to, like really interested to do good projects guided by our experienced naval architect, you can let us know. But only thing is students should be serious, not that we have to be after them, do this every day. So if you are serious, really serious, you can come to us and we will help you in doing projects.
Thank you, sir. Then we thank you, sir. We'll move on to some of the other questions. Primarily something a very senior naval architect, Mr. Kamal Palit, is not able to connect. Hopefully, you'll be able to connect and add to our discussion, sir. We will. I would request Amir to add Mr. Palit to the forum, and as and when your speaker is ready, sir, you can just please add your thoughts, sir. So you are added to the panel, sir. You can please add your thoughts to the audience, sir.
Hello.
Yes,
Hello.
sir. You're audible, sir. You can please add your thoughts.
Yes. Okay. I have a very long talk. If you have time, I will take probably about 10 minutes to give my remarks. At first, I congratulate our chief guest, Mr. Girish, for covering all opportunities of a naval architect. I remember during my visits to IRS, he used to discuss on various areas of working of naval architects. He is one of the greatest supporter in IRS. Secondly, I congratulate Captain Manoj Kumar for informing about the opportunities of a naval architect in Indian Navy. Mr. Manoj Kumar, I would like to mention to you that very soon I am meeting Commander Santanu Bose, who is in charge of shipbuilding at GRSC Kolkata. See, this is the greatest intellectual power of the naval architects. And thirdly, I thank Mr. Jathesh Chandra. I remember a few years back, CSL had built and delivered one of the large aircraft carriers, that is the opportunity of a naval architect. I'm talking of the opportunity because our subject is opportunity of naval architect. I also like to inform Mr. Jathesh Chandra that Mr. Sundaram, a very senior naval architect who is the first batch naval architect from IIT Kharagpur, and myself took delivery of the first Panamax bulk carrier Rani Padmini from CSL. And fourthly, I thank Mr. Ankur Anal. I, being a naval architect from IIT Kharagpur and having worked in SCI and Indian Steamship Company, Kolkata, for 50 odd years, I agree with Mr. Ankur Anal about the opportunities of a naval architect. And lastly, I thank Mr. Hariraj for your presentation on the opportunities of naval architects in India. But I feel that we naval architects, having graduated in India, we should not leave India and go abroad. There are enough opportunities in India. I remember that during the first 2-3 batches who passed out from IIT Kharagpur, there was not enough opportunity in India. So they went abroad. But now in India, we can build, the naval architects can build and design and build all types of ships, large and small. I also like to agree with Mr. Hariraj that in these years of requirement of decarbonization in a year, as a matter of fact, a long time back, while I was working with SCI, we, that is Mr. Sundaram and myself, tried to change a normal propulsion system of a bulk carrier to a sail-assisted propulsion system. But unfortunately, the ship operator, they did not agree to release the vessel. We had collected all data because we were trying to operate from Kolkata. Those days, if I remember, the passenger ships, there were 2 passenger ships, Andaman and Nicobar, which were operated from Kolkata and Chennai to Andaman and back. So we tried to take the wind in those directions to help in propulsion and save fuel. And lastly, I wish to say that we naval architects, many people do not agree, but I feel that naval architects are most intelligent. We can design, we can do all types of calculations, stability, all dynamics, propulsion system. Propeller is one of the most important part of the ship, and those propulsion system, wave directions, wave dynamics, everything we have learned, and we can do all that. And we can do also shipbuilding. In shipbuilding, also I would like to say that it is the very strong energy is required, because we have to go up and up the stages to see the constructions of the ship. Can you hear me, sir?
Yes, sir.
Hello?
We can hear you, sir.
Clear, sir. You're clear, sir.
Okay.
Please continue, sir.
Okay, okay. So we can do the design. I remember that when I was working with India Steamship in Kolkata, as a naval architect, they told me that you are the only naval architect. You have to do the design as well as construction of 4 Panamax size bulk oil carriers from Hyundai shipyard. So I myself used to come to Kolkata and check the designs, go to Hyundai shipyard and discuss with the designers and also see the construction. Similarly, long time back, when I was working in SCI, Government of India, they desired that one naval architect and not a marine engineer and not an electrical engineer should go to Holland, because we were building that time the largest container vessel. And they said that we want Mr. Kamal Kumar Palit to go there. So this is what I would feel. I am not talking about myself. I am talking of the whole naval architects, all the naval architects. And I must say that we naval architects, we are really intelligent, and we should continue our effort in all to support Government of India. Now, you know that Government of India is also thinking of, we have got our present government is also thinking of small crafts from starting from Benares to Kolkata, small craft. Because
just
there
one,
is
sir, just one request, sir. There are a lot of questions which are there from youngsters.
Okay.
It is time. We need to give them time, sir. Thank you so much for your kind understanding.
Thank you. Bye-bye.
Thank you, sir.
You are mute.
We've got a question on biofuels actually. Handling biofuels and methanols is also quite difficult. And for that, we need specialized storage system in the ship. And also the high calorific value of natural gases can increase carbon emission. Could you please elaborate on this? So, this question...
Of course, it's he's talking about various things. One is biofuel, then LNG. Okay, biofuels definitely is a drop-in fuel, which we can easily, it's not much difficult to use biofuels along with other fuels. And biofuel blends are being tried out. We are using it in India. In fact, we have done extensive trials of biofuel blends. And biofuels are to be stored separately, and then storage. There are issues. You cannot store it for a long time because they may get disintegrated. There are some problems with long-term storage. So we can only store for a short time, maybe 2 months or 3 months. So within that time, we should be able to consume that fuel. First, so vessels on coastal voyages and all, very easy to do that. And biofuels, in fact, IMO has come out with a recent circular which says what kind of biofuels can be accepted for the purpose of using it in the CII regulations. If you use biofuels, you can reduce your carbon factor. So you can improve on the vessel's emission, CII rating will improve. So for that, only those biofuels which are more than 65, give you more than 65% reduction in GHG are allowed as per the IMO circular. Biofuel will definitely has got potential, but it has got also competition from other the food industry. So there is also a limitation to the amount of biofuel which can feed the shipping industry. Then coming to the other question of methanol, of course, methanol has got a lot of problems like toxicity is one of the main issues. So then also the fire hazards, explosion hazards are also there. So there are, in fact, methanol regulations are there. In fact, IMO has made some circular, and classification societies like IRS also made rules for guidelines for methanol fuel vessels. These are available. Methanol engines are also available now, like ammonia engines. Methanol engines are already available. And in fact, a lot of container ships are going in for methanol-ready ships. So whenever methanol is available, they will be shifting to methanol. Of course, methanol, the problem with methanol, the calorific value and all, there are some problems because you need more fuel because you can't, it's only half of what you get from diesel oil. So then you need much more fuel compared to, the tank capacity will go up. That is the problem with methanol. I don't know, the question on LNG, I didn't understand clearly. Finally, there is something on LNG maybe.
So he was talking about the high calorific value of natural gases can increase carbon emission. That was a comment, and can you elaborate? That was
Yeah, the natural gases, they have got carbon emission factor. I agree, but LNG is not considered as a kind of a alternative fuels as far as in the long term. Initially, you may use it for some time, but slowly it will be probably taken over by other fuels, which will give less carbon emissions. Definitely, there is carbon emission from LNG. Otherwise, we have to go for carbon capture. If you have a carbon capture system on board, then you can capture the carbon and then go for sequestration. So then LNG can be a good solution. LNG with the carbon capture. Maybe Mr. Dasgupta can add something about carbon capture. He was an expert on that.
No, thank you. We'll discuss that afterwards.
Yeah.
So let
Okay,
the other
thank
questions come in.
Yeah,
Yes,
Okay,
yes.
thank you.
Perhaps not in the same order, but since there was a lot of questions on fuels, I'll just put the other question on fuel, then I'll go chronologically. Mr. Jibin has asked, hydrogen is considered as an alternate fuel, but is highly inflammable. Can you please talk about how to handle hydrogen as a fuel? This was the question. So,
Yeah, I think any of the panelists, they can.
yeah.
Yeah.
Jathesh, yeah.
You want me to?
Yes.
Yeah, hydrogen is highly inflammable, but there are guidelines coming in and being prepared by IMO on the IGF code. That means for using gaseous fuels. We, as you know, we have been developing a hydrogen fuel cell ferry, which testing going on, the FAT of the fuel cell is going on. There we have used the hydrogen cylinders, which are carrying hydrogen in 350 bar. And there is acid and HAZOP study to be done for any leakage or any hazard which is because of any leakage, and there is clearly a distance to be made from any possible or potential leakage areas for intake and other any kind of ignition that could trigger. So there are guidelines and codes available, but this is still being developed and improvement are being made.
Thank you, sir. Now, one question is basically on what is the scope of incorporating machine learning and artificial intelligence in various fields of naval architecture? Of course, people are concerned about job opportunities, but the main question is about incorporating machine learning and artificial intelligence in the fields of naval architecture.
Sir, I think to start with, one of the topics which we were discussing, very relevant, autonomous surface ships. So there's a lot of data to be analyzed, crunched, and then machine learning has to come in. If they're specifically, just to give them example, they can look up the web for, I kind of remember NYK did a trials, which was like a remotely operated vessels trial. And then you could look at companies like Siemens or Dassault or other companies which are working in this field. So a lot of data which is coming from the ships has to be analyzed, and then proper systems AI has to be used to take the calls to be able to operate the ships initially remotely and then autonomously. So there's a lot to be done in that field, and obviously the digitization will also require a lot of machine learning aspects with the vessel vessel performance and such aspects.
I would like to add, please, with your permission, I would like to add something that I was telling about the academic R&D and CFD and all those things. One of the latest techniques which is being, particularly in turbulence model, which is coming, is using the AI/ML techniques for the turbulence modeling, not the classical or the traditional K epsilon or K omega model. But increasingly, AI/ML techniques are coming into the turbulence modeling, which is particularly required for me to, get the viscous pressure drag and particularly the frictional drag and all those things. So there's a lot of these things that can I reduce the requirement of computational power. I was previously talking about using 1000 cores and all those things, but using AI/ML techniques, can I bring it down to a level where it can be operated by say nowadays, since we are using workstations of 16 to 32 cores, can I bring it if I properly use AI/ML tools for turbulence modeling? that is another active area of research which is actually happening. Just to add to it for specific naval problems, both related to hull form and propulsors. Just want to add to that. And I think Amir wanted to say something. I just see that he's raised his hand. Amir, yeah. Amir, you're on mute, Amir. You can just unmute yourself. And,
Yes, sir. So just wanted to add couple of points on this. I was a little reluctant in speaking in between the esteemed panelist.
Please,
But
please.
yeah, so I have about just a quick intro. So I have about around 11 years of experience in the offshore oil and gas industry, and I've got a chance to work in multiple IT industries also. So I've worked in Oracle and few other companies where I've got a chance to use this machine learning. So I was thinking that I can add few points to it. So in the last 12 years, we have seen a huge transition on how the oil and gas industry is operating. So if you speak to me about 11 or 10 years back, there we didn't had all these, because that time the oil price was around $140 when I joined the industry, and that time we used to and in fact I think Mr. Hariraj also mentioned that earlier, that 5% of the total cost was going to design. But oil and gas industry is a very dynamic industry. Like, it has seen the 2014 downturn, and after that we have seen a huge transition, going from the 5% design to reduction it. So in fact, I'll say at this point, almost all the oil and gas, at least that from the design and technical consultancies, have built a machine learning and AI team in their companies. In fact, and they have been so this is basically to how to reduce the cost at this point, because the oil price is very dynamic. But one more thing is that not just having the background of machine learning is adequate, we should also know the application where we'll be applying. So there, this naval architecture background will come in. So it's not just that if you have the machine learning background or AI background, that is adequate. So for example, you have to find the application where you are going to apply it. It could be like corrosion detection is one of the things what a lot of companies are working on. So definitely companies are they are sponsoring projects into this. It's still a little bit in the nascent stage in oil and gas, but a lot of sponsoring is happening. So definitely this is one of the field where in fact in the recruitment also nowadays we are already looking for people who have this background in coding, Python, and then including this machine learning. So I think this is a good opportunity right now that is coming up.
You're mute, Dr. Iyengar.
Yeah. Thank you, Amir. Now, I've just seen repeated questions because of probably our answers. Like, how much will the soft skills on knowing the CFD softwares, like ANSYS and OpenFOAM, will help us in, say, the opportunities? That is some question probably somebody has posed because of the way we answered on how we look at this software skills. Probably Mr. Hariraj or Mr. Jathesh can add to how we look at specific, say, skills like ANSYS or OpenFOAM when we look to recruit people. Probably they can probably add to it.
Hari, you would like to, or otherwise I can.
Yeah, you go ahead, Mr. Jathesh.
Yeah. As we discussed earlier, AutoCAD was something which was considered very sophisticated software when we passed out. Now even CFD, OpenFOAM, a lot of things students are doing. Even in the college, BTech college time itself, they are doing problems in CFD. OpenFOAM is freely available it's a open software, and you can do drag calculations and also propeller calculations in design in using CFD, this OpenFOAM or ANSYS. And also you can do the simulations on dispersion and the plume studies using this. So definitely this is an added advantage. And I would say without this, I think now model tests are being replaced. Most of these tests You will get a lot of insights initially itself during the design stage itself. With the CFD calculations, you can optimize to a large extent using CFD softwares at a very beginning stage itself. So these are going to be a very, very important tools and a must tool for future naval architects. Designers, those who are going into in the design field, not maybe in the construction field. Yeah. And of course, we are looking at optimization of hull form and reducing carbon emissions. So this is going to be a must now.
Thank you, sir. Now, perhaps this is the final question of the day. And perhaps this is the most generic question that somebody is looking for opportunities is going to ask. That a student wants to work in design. Is it recommended to directly work on design or going for production as a fresher? This is the most generic question. And so perhaps the panelists can take on this question. Yeah.
Yeah, I think it is something which maybe I can, I also can give some inputs there, because definitely a designer is actually a, yeah, I think naval architect, especially, you need to have a passion to do design, and the product coming out should be really good. It should be aesthetically good. It should be efficient. It should meet its functions and missions. So these are all required. And so basically you are a creator, and there is no limit to the creativity. You can fine tune it and you can do it to the best of best. So to do that, and it should be constructible also. So we should know the production, whether it is producible. Sometimes if you know the production issues, your creativity thought process will be bound by that, restricted by that. The creativity may be limited. So if you are able to create good ideas, good designs, it may be difficult to create or produce, but there could, if there is a way to produce, and if it is producible in somehow, that is also workable, but may not be a cheaper solution. Like for example, if you look at some, maybe just take the case of an FRP superstructure. FRP superstructure or FRP boats, some of the we have got production limitations here. If you look at the shapes which you have to select, mostly the if you know the construction issues, you will go for a rectangular construction. You will not have complicated shapes, because the mold will not be able to take it to, or you need a lot of money to make a mold which is aesthetically looking and very maybe reducing resistance. But for constructability point of view, you may go for a very rectangular shape, but it may not look good. So when you know the production issues, your creativity sometimes gets restricted. But of course, knowing things is advantageous. It's you need to balance both creativity and productivity and yeah. I hope I have answered, but yeah.
Yeah, can I just come in here? If I may say, I think it is always helpful to have actual yard experience, because specifically with regard to producibility as well as from operability point of view. So if you're getting into detailed engineering, detailed design part of it, then having worked in the yard actually is really helpful.
Yeah. I think here I need to add one more thing, sir. We were dealing with one, Norwegian clients. Yes. So what has happened there is literally not much of shipbuilding happening there. So the naval architects there, they do not have production, means they have not seen ships. Actually, they have not touched a ship, or they have not felt a ship. So here in India, you can get that opportunity. You have got shipyards where you can see, you go for trials, and yes. The people who have done there, it means the recent generation of naval architects, they were telling that they don't have that much of exposure. They have to come here or maybe to China to see the actual construction of complicated ships. So they are based on, their design is based on the previous experiences from their seniors, or maybe the knowledge base which they have, or maybe the software tools they have.
Yeah, I think Mr. Girish is the right person to talk about it. But I would say that sometimes the rules can be interpreted in different ways, and solutions can be obtained. And not all solutions are production friendly and operation friendly. So the right solution needs to be arrived at. So just a little bit of exposure onto the actual ship, especially in constricted areas, as to how people can operate and work, or they can be produced. It helps a lot. It helps a lot. Yeah. Thank you.
Thank you, sir. Now, there's some more. Another general question is, will there be any job reduction due to AI takeover? This is.
Can I answer
please.
this question, sir?
Please.
While I may not be the best candidate to be answering this question, AI/ML has also been a field of interest for me, and I generally am closely following this field of research and development. I would like to, very lightly put it that artificial intelligence will only be replacing natural stupidity, and I believe naval architects are some of the best in terms of, as we already discussed previously, in terms of smartness, overall approach to a subject, and otherwise. So whilst we will be seeing a lot of improvements in AI, ML in terms of large language models replacing a lot of industries, I honestly feel that AI, ML will only be enhancing the overall capability of naval architects if they are able to use this to improve their own capabilities. And I don't see AI/ML replacing jobs of naval architects. I only see them augmenting our capabilities in the future.
Sir, again, there are a few added questions on internship opportunities. I would request again and emphasize that they can contact the individual organizations through their faculty coordinator, and it can be taken up there. I leave at it. Jathesh has actually talked about the internship opportunities at Cochin Shipyard. As far as other organizations are concerned, their faculty advisors can write to the respective HR departments of the organizations, and it will be taken up. And similarly,
there was one question regarding UES also, sir.
Yeah.
So I think Manoj sir has already given his contact number to you, sir. He's actually the right person, because he's dealing with right now the all the enrollment aspects for naval architects, specifically in the Navy, in DNA. So I think he is the right person. And I would also request anybody interested in joining. The latest joining prerequisites are clearly outlined in the Navy portal, sir. That will be the best place to visit and see the basically your educational qualifications and requirements as defined by it. That would be the best place. So I think that should meet the requirements, sir.
Yes. So with that, I think there are no further questions, sir. Now I'd request the Chief Guest for his final remarks before we conclude the session. So please.
Yeah, thank you once again, because this is a very interesting session. A lot of discussions we had. Panelists also explained a lot of the doubts and questions. So through that, many doubts in the mind of the students, they have come out and we have explained. There are more things, maybe there could be more things which we can even discuss further, maybe in person or through other channels. It's possible to discuss, but definitely a very challenging period for everybody. As I said in the beginning, this is an area, this is a kind of a big revolutionary change happening in the shipping field with the decarbonization. Not like such big changes come only once in a while. So you can be part of this change, and this is a big opportunity for everybody, especially naval architects, to design new ships with new fuels, new technologies. And this is an era which is going to come. So this is the area, and this is a time to enter into this field. So I congratulate all naval architects who are coming into this field, and we request them to stick with the field and learn and grow. Thank you. That's all I would like to say.
Thank you, sir. There was an added last minute question on whether somebody can enter in research. I would just request that he can contact me personally and then take it as a more personal question. He can always contact me personally and answer. With that, sir, we are almost come to the end of today's interesting discussion. It was a very lively discussion and almost 100 participants from various institutions. So this is my opportunity to thank all the panelists, starting with Mr. Girish, with all his 4 decades of experience. Yes, eminently, even in his opening remarks, set the tone for the whole discussion with all the technologies and which is completely covering the complete gamut of naval architecture. And the panelists, Commander Karthik Das, Mr. Ankur Mr. Jathesh Chandra, Mr. Hariraj, and also we had Mr. Palit, who actually joined our panel and offered us decades of experience with very useful comments. And Mr. Amir, who I would usually separately thank him for organizing the webinar as a good backend support. But at the right time, he also came in and added his thought process. So I'll consider today that you're a complete panelist. And thanks for joining and adding your thoughts on particularly AAML, which is very nice in the offshore industry. So Amir is usually the background, but today he came to the foreground and I thank him for that. And also I thank the faculty specifically because we are also given invitations to the faculty to circulate among the students. Professor Vishwanath Nagarajan from IIT Kharagpur, Dr. Vijay Kumar from IIT Madras, Mr. Abdul Rahman, who is the student coordinator secretary from CUSAT, Professor Prasad Rao from Andhra University, Dr. Shija Janathan from IMU, and Professor Sivabalan from AMET. We had personally mailed them to ensure active participation of students. And that's how we were able to get a very good student audience of around 100, which is, I thank all the students also who had joined and all the panelists for offering their insights and making this a lively session. Thank you and good day and good evening.
Thank you, sir.
Thank you.
Thank you. Bye-bye.
Thank you. Bye.
I'm closing the session.